Hi guys, welcome to my channel. And in this video, I'm going to go through this Leetcode number 230, kth smallest in a binary search tree. So a good thing about binary search tree is that the number has been sorted. So everything on the left hand side will be smaller than the root, and the root will be smaller than everything on the right hand side. So let's take a look at this example in here. The root is right here, 3. And things on the left hand side, there's a one smaller branch which has another root of 1, and and it has no left branch, and also it has a right leaf node. So as you can see, both these two numbers they are smaller than 3, and also if there was a number on the left hand side of this branch, it will be smaller than 1, and the number on the right is bigger than 1. And also all the number on the right is bigger than this guy, all the number on the left hand side bigger than that guy. So all the number have been sorted in a particular way. I think this is another good example that we can take a look. So as you can see, following the rule, number on the left hand side is smaller than the root node, and number on the right hand side is bigger than the root node, and everything on the left is smaller than the upper root. As you can see, so everything on the left is smaller than 5, and everything on the left over here is smaller than 3. 1 and 2 are smaller than 3, and things are on the right of the 3 is bigger than 3. So in this branch, actually it's only one leaf node. That number, so everything on the right has to be greater than 5. In this case, even though there's only one node, and that's greater than 5. So immediately there's one approach to list this number in an order. There will be a in order tree traversal. So basically, what in order traversal does for us is it display the numbers on the left first, and then the root node, and on the right. Again, so it's left, root, and right. So this is exactly will help us to display all the numbers in an order, right? Left, the smallest, root is in the middle, and then the right is the biggest. And then because we will have to find the kth smallest element, so this we have to display the number in some sort of order. So that's exactly the order that we need. So basically, this answer will become a application of an in-order tree traversal. So let's do that together, and we will solve that by using a DFS. So first we have a stack that will keep track of the nodes that we are working on with the temp root, and we initialize the temp root as the current root, and also the minimum count. So we keep track of so the first minimum count will be the smallest number. The second minimum count will be point to the second smallest number, because we need the kth smallest number. So when this guy is equal to k, and this is where we're going to return. So while there's something in the stack, or the temporary root is not empty, and then this chunk of code keep collecting, so pushing all the left node to the stack. So basically, it goes from here, we go all the way to here. So we push this guy to the stack, push this guy to the stack, also this guy to the stack. And then when we pop off from the stack, the latest, so a stack, the rule for stack is last in first out, right? So the element that being pushed in at the end, at last, will be this nodes right here. So it's right at the bottom, which we have to deal with first. So the temporary root is the stack pop, and then we collect the number, and then the mean count. Not to collect the number yet, because we haven't hit the mean count. No, it's not yet equal to k. So we increase the mean count by 1, which is means that it's currently is the smaller the smallest number. And then if there is something on the right, we collect that and push it to be the temp root, and then flow back to here. And then when we are here, by popping off from the stack, and then increase our mean count, and then do again, and then the next one we are here, and now in here where there's something on the root on the right, and then they will push it to be the temporary root, and then jump back to this while loop here, but there's nothing on the left of this right root. That's why this chunk of code is not being executed for this node. And then pop it off again. So it will keep doing that until we collect. We are looking at the third smallest number. This is when the mean count is equal to 3 for this particular example. I'm just walking through this example. I think it's very easier to walk through the code together. And yeah, that's basically it. So when we hit that, and then we will run the kth smallest number. In this case, it's the third smallest number. Submit that. Yeah, it looks pretty efficient to me. So in terms of time complexity, we are running the DFS k times. It's exactly k times. So time complexity is a bit of k, and for space complexity, it's b of n. In this case, it's n number of root. So number of root nodes for a completely imbalanced tree. So there will be the worst case, that will be of n, because we keep collecting the nodes on the left until we collect all the nodes. So everything will be pushed to the stack, and that takes a little bit of space. Yeah, that's basically my solution. I hope you like it. If you do, please like this button, hit the like button, and consider subscribing to the channel. That will be a huge encouragement to me to create future videos that looks like this. Thank you so much for watching. I will see you in the next video.